This question is about a tribasic acid. Tribasic, which also means triprotic, same thing. So you have here three dissociations. The first one is this one. This is dissociation 2 and 3. And what the masking tells you is that the first dissociation happens to a greater extent than the second, and the second to a greater extent than the third one. And why is that the case? Well, let's think about acids and conjugate base. In the first dissociation, we have phosphoric acid. That's the acid. When it dissociates, you get a conjugate base. The base can take a proton and then go back. However, in the first dissociation, that hardly happens. Whereas in the third dissociation, the backward reaction does happen very much indeed. So why is that the case? Well, I'm going to introduce the concept of strong and weak base. Strong base is the one that can take in protons very readily, as opposed to a weak base which hardly takes any protons in. So if you think about, let's say, phosphate ion as a base, and you compare it to H2PO4 minus, then what you will see is that in here we have a 3 minus negative charge compared to only a 1 minus negative charge. So phosphate PO4 3 minus is going to attract the protons much more strongly than H2PO4. Therefore, the backward reactions is favored, which means that the dissociation of the acid is less. Therefore, if you have less dissociation, Ka is going to be smaller. It's going to be quite low. Whereas in the top equation, the first one, because you have hardly any backward reaction, most of it is just forward, then the dissociation is much greater and Ka has a high value. The second dissociation is going to have an intermediate value of Ka. And that's one way of looking at it. Another way of looking at this question is we can think about the acids. So the acids are going to release protons. If you think about HPO4 2 minus, you have already a 2 negative charge. So the attraction that there is over this hydrogen is very strong. Therefore, this hydrogen is not going to be released easily. If you compare it to one of these hydrogens, where there is no negative charge in the molecule of acid, then the hydrogen can be released more easily. Therefore, you have greater dissociation. But then, if the Ka is the highest in this case, that means the pKa would be the lowest. So this one will have the lowest pKa. And this one would have the highest pKa. Because remember, pKa equals the minus log of Ka, which means if Ka is very high, when it becomes negative, that makes pKa very low. And inversely, if Ka is very low, pKa is very high.